You know, when you think about a logical argument, what comes to mind? You've got your premises, your reasoning, and it all leads to one conclusion, right? Well, what if I told you that's just a choice? We're about to dive into a fundamental concept that literally splits the world of logic in two: multiple conclusion logic.
So let's just ask it straight up. Can a logical argument have more than one conclusion? I mean, your gut reaction is probably, no way. An argument's supposed to prove a single point. End of story. But what if allowing for many possible conclusions actually unlocks a way more powerful way of thinking?
All right, so what are we even talking about here? Multiple conclusion logic is pretty much what it sounds like. It's about logical systems where a single line of reasoning, a single deduction, can lead to multiple conclusions. This isn't some newfangled idea either. It was really laid out back in 1978 in a book by Shoesmith and Smiley. And as we're going to see, the consequences are profound.
Okay, so here's our game plan. First, we'll get to the heart of the matter. One conclusion or many. Then, we'll see how this single choice creates this massive split between two major logical systems. After that, we'll jump into the philosophical dogfight it started, see how this idea spreads beyond its original home, and finally, look at how modern logicians are just running with it and pushing the boundaries like crazy. All right, let's dive into section 1, one conclusion or many. And to really get this, we gotta hop in a time machine and go back to the 1930s to meet a logician named Gerhard Gentzen. He's the guy who created this amazing framework called sequent calculus, and it's basically the perfect stage for this whole drama to unfold.
So this thing right here is a sequent. Now, I know it looks a little mathy and intimidating, but the idea is actually super simple. On the left side, you've got your assumptions, the stuff you're starting with. On the right, you have your conclusions, where you're trying to go. And that little symbol in the middle, you can just think of it as therefore or leads to. That's it. It's just a clean way of saying these assumptions leads to these conclusions.
Okay, now here is where things get really interesting. That simple structure we just looked at, specifically what you're allowed to put on the right side of that therefore symbol, well, that creates this massive fork in the road. It splits logic into two completely different worlds.
So if you take one path, you end up in the world of intuitionistic logic. And the rule here is simple and it's super strict. On the conclusion side of your argument, you are allowed at most one single formula, one statement. That's it. This is that single conclusion framework that, probably feels the most natural to most of us. But if you take that other path, you land in classical logic. And here the rulebook gets a total rewrite. The conclusion side isn't a single point anymore. It can be a whole collection of statements. You can have more than one conclusion, all flowing from the same set of assumptions. For a lot of logicians, this is the most natural way to represent classical reasoning. And this is the part that just blows my mind. When you put them side by side, the only structural difference between these two massive systems of logic is this one rule: single conclusion versus multiple conclusions. It's like flipping one tiny switch, and suddenly you're in a completely different logical universe. It's wild.
Now you might be thinking this is just a technical detail for logicians to argue about, but it's so much more than that. This is a deep, fundamental, philosophical debate about the very nature of meaning and truth. This brings us right into a philosophical battleground.
So the debate really boils down to this: where do logical statements get their meaning from? The single conclusion camp, they're the traditionalists. They argue that meaning comes from a clean, direct proof for a single statement. But that view really struggles to explain classical logic. Then you've got the multiple conclusion camp. They say, hey, you need multiple outcomes to make any sense of classical logic. They see it as a natural side effect of how words like or and if-then work. The other side fires back, worrying that this creates a messy, circular situation where the meaning of your words all depends on each other. It's a real tug of war.
But this powerful idea of having multiple conclusions wasn't going to stay locked up in just one system. Oh no, it broke out and started showing up in other logical frameworks as well, which leads us to logic beyond sequence. So, fast forward to the 1950s. There's this logician named Kniel, and he's looking at another famous system called natural deduction. And he basically thinks it's a mess. He called it asymmetric and unnecessarily complicated. So what was his big idea? Let's fix it. Let's generalize it to allow for multiple conclusions. And what's so cool is that it shows how connected all these ideas are. Turns out, his new system was really just a different way of writing down other logical tools that already existed.
Okay, so we've established this fundamental choice between one conclusion and many. But modern logicians? They've taken this core concept and just run with it.
pushing it into some truly mind-bending territory. And that brings us to the future of logic.
Yeah, think of this as an evolution. We start with our standard two-sided argument, assumptions on one side, conclusions on the other. But then, logicians started thinking, what if we stack these arguments on top of each other? And bam, you get hypersequence. But why stop there? They went even further, creating polysequents with many, many sides. It's really like going from a flat two-dimensional argument to this incredible multidimensional logical space.
And this isn't just about making things more complicated for the fun of it. Absolutely not. These superpowered frameworks are the tools you need to tackle concepts that traditional logic just can't handle. We're talking about stuff like fuzzy logic, where things can be kinda true and kinda false at the same time. Or modal logic, which deals with possibility and necessity. These are systems that go way beyond a simple black and white true or false world.
And that leaves us with one last, big, provocative thought. The idea that an argument has to have one and only one conclusion. I mean, that feels like it's just baked into the definition of logic itself, right? But as we've seen, it's not a rule from on high. It's a design choice. It's a setting you can actually change. So, if we can change something as fundamental as the number of conclusions an argument can have, what other unbreakable rules of logic are just waiting to be completely reimagined?